Today we're going to look through one example as to how our parabolas how find the max and min for parabolas can be connected to domain and range. All right, so we're going to work on this this problem right here. So we're going to find the x-intercept and y-intercept, max or min, in the domain and range for y equals x times 50 minus x. Now, something that might be good to remember is the general form for a factored quadratic equation. It is this. Now, in this general form, what are our intercepts?
The m and the n.
The m and the n, right? M and n are the intercepts. Yeah, so if I look over here, what's my m and my n value? Looks a little different, doesn't it? Mark, what do you think it is? 0 and 50, that's exactly right. Okay. This x, there's nothing subtracted from it, right? I could rewrite it like this. Y equals x minus 0 times 50 minus x. Could rewrite it just like that. Okay? But instead of doing the minus 0, we just left it out. Okay? So our m is, what's our m again?
0.
0. What's our n? What is it?
50.
50. So, since m is 0 and n is 50, m is 0 and n is 50, can we find our x-intercepts?
Yes.
Yeah, what are they? Okay, it crosses the x-axis at 0 and 50, right? So that means that our x-intercepts, right up here. Our x-intercepts then are going to be 0, 0 from m, right? And 50, 0 from the n. Okay, you guys remember doing that yesterday? Yeah. So that means over here, we're going to cross at the origin, and I don't have tick marks, but we'll just call that 50 right there. Okay, so it'll look like that. Now the next thing we need to find is what?
No, y-intercept.
Yes, we do our x-intercepts. We're going to find x. Y-intercept. When does the y-intercept happen?
Once it crosses the y.
When it crosses the y-axis. So what's 0, Doug? What is? X. So when x is 0. So for the y-intercept, that means x equals 0. Right? The y-intercept, that means x equals 0. So I take this equation. What do I plug in for x?
0.
0. So we do y equals 0 times 50 minus 0. What's it going to be, Matt? 0. Because 50 minus 0 is 50. 50 times 0 is?
0.
0. So then our y-intercept is what?
0, 0.
0, comma 0. Okay. Which is the same as an x-intercept. Okay. So we can notice here is anytime you have 0, 0 as an x-intercept, then it's also your what? Y-intercept. Okay, you can save yourself a step in that if that happens.
So you always have to times that? Like the 0 and the 50?
If you're going to find the y-intercept, okay, you have to plug in 0 for x. Now this is our equation, so that's why it's 0 times 50 minus 0. Okay? Well, because we didn't know that to begin with, so I was showing you that. I know, but you guys didn't. Okay? So if you get 0, 0 as an x-intercept, then you don't have to do this. Okay. Right? All right. That was just the equation, so we had to do 0 times that. All right? It all depends on the equation they give us. Okay. Any questions about y-intercept? Any other questions? Brock, does that answer your question? Okay. All right. So now we got our x-intercept and our y-intercept. What's our next thing?
Max or min.
Max or min. Okay. Now, first thing we had to figure out, is this a max or min that we're finding? What do you guys think?
It's a max.
Okay. Austin, you say min. Why do you say min?
It's a positive.
Okay. There's no number out here, so we can assume it's a 1, right? Right? So we have a positive 1 right there, so Austin thinks it's a min. Right? That's a good idea. What is he right?
No.
Oh, why not?
Because you don't know what x is.
Nope, that's not right, John. Okay.
Oh, because x.
Austin made a good observation, but he missed this part.
Oh, yeah,
The-
they tricked you and it's a negative.
They flipped it on us, didn't they? They did 50 minus x instead of x minus 50, right? Remember when they flip them, when they're in backwards order, that means our a is what? Negative. That means they're hiding the negative on the a, right? So Austin is gonna be max or min?
Min.
Nope.
Max.
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 Okay.
If our a is negative, it's gonna open down, right? It's gonna look like this. That's gonna be our parabola, right? So we're gonna have a max or a min?
Max.
A max. So that point right there is gonna be a max. So we're gonna try to find a max. Now, to find a max, remember x max or min, we do m plus n over 2, right? What's my m value?
50.
0. What's my n value?
50.
50. So the x coordinate of my max is going to be at 0 plus 50 over 2.
25.
25.
Thank you, sir.
So my x max is going to occur at 25. So right here, that spot right there is 25. This spot was 50. That spot was 0. Okay, that spot right there is 25 on the x-axis. Right? How do I find the y-coordinate? Whenever I know an x, how do I find the y?
Is that the order?
Plug it into the equation. Good, thanks, Austin. So we take this 25 and we plug it into this equation, right?
For X.
For x. So let me do y equals 25 times 50 minus 25. 25 times 50 minus 25. What's 50 minus 25? 25. So this ends up being 25 times 25. What does that equal? 25 times 25.
625.
625. Bigger than you thought, right? Okay. So that means the y coordinates of our max is what?
625 and 25.
625. So our maximum occurs at 25, 625. So this point right here is 25, 625. Okay. So now we found our max. Do we have to find a min? No? Why not, Davion? No, you're right. You said the right thing.
I said no, there is no.
We already have a max, right? You can only have a max or a min, not both. Right? So once you find your max, you can't find your min. Okay? Because there isn't one. Right? Once you find your max, there is no min. Right? Just like if you have a min, is there going to be a max? No. Okay? But we use the same process to find them. If we were finding a min instead, we'd use the same equation, plug in just like we did to find the max. All right? It's the same exact thing. What?
So once you find either of them, it's not a.
There can't be another one. Yep. Once you find a max, there's no min. Once you find a min, there's no max. Okay. Now the last thing I want us to do is I want you guys to find the domain and range. Now we talked yesterday about using graphs to find domains and range, right? Right?
No.
Now if we're using the graph completely, then what are we finding? A practical domain and range or a theoretical domain and range?
Theoretical.
Theoretical. We also know we're finding theoretical because they didn't give me a word problem, did they?
No.
They didn't say, here's the equation for the number of people in the classroom and the number of socks in the classroom, right? I know that wouldn't work, but they didn't give me a context, did they? No. So since they didn't give me a context, all we can find is our theoretical domain and range. Okay? All we can find is our theoretical domain and range. So, using our graph, what's our domain going to be? Anybody know? Okay, look at the graph. Are there any x's that won't have a y?
No.
Are there any x's that won't have graph either above it or below it? No. So that means every x can what? Every x has a y, right? Every x can be plugged in, can it? Right? Every x has an output, right? So what's my domain going to be?
Any number.
Any number. So our domain will be all numbers. So our domain will be all numbers. Now continuing to look at the graph, what's our range going to be? Range is our y's, right? What's our range going to be? Is there any y that doesn't have a graph either to the right of it or to the left of it?
No. Any positive, all positive.
This y down here is the graph to the right and the left. So these y's are good, right? All the negatives are good, right? These positives are good, right? What about the y way up here? Does it have a graph to the right of it?
No.
What about to the left of it? No. So what's our highest one, Austin? 625. Since 625 is our maximum y value, this is the highest y we can have. So can our range go above 625?
No.
No. So Austin, you're about to say, what is it?
Every number under 625.
Does it include 625?
Yes.
Yeah. So it's all numbers less than or equal to 625. That'll be our range. Okay. So this is kind of combining our theoretical domain and range from last week, right? From the adventure we had last week, right? With what we learned yesterday. Okay. What? Okay. So what I'm trying to show you is that the information we used yesterday, or the things we learned yesterday, can be used to figure out our domain and range from last week. All right. You don't have to think of them as two independent things. Okay. They work together. Right. And if you're ever having trouble finding domain and range, what do you think you should do with your equation?
Plug it in.
Plug in where?
To y.
To the y equals under calculator, right? If you're ever having trouble finding your domain and range, graph it and then think about, okay, where do the x's have graph above or below? Where do the y's have graphs to the left or the right? And then it'll help you figure out what your domain and range are. Now you might have to zoom out a bunch of times, right, to get the whole graph, but that's okay. All right? Are there any questions? Any questions? All right. What we're going to do now is we're going to look at page 334 in the book, number 4. Okay.